Hi everyone, you are welcome to physics class online. Kindly subscribe to this channel, like this video, turn on the notification bell and comment. Please subscribe. Please subscribe. Alright, today we will be looking at equation of uniformly accelerated motion. In previous classes we looked at the fundamentals of motion and we concluded that class by stating the equation of motion of uniformly accelerated bodies. And today we'll proceed by applying that equation of motion to solve some questions. Alright, let's look at those equations once again. 1. V equals to U plus AT. Number 2. S equals to UT plus half AT square. Number 3. V equals to V square equals to U square plus 2AS. And number 4. S equals to half U plus V close bracket T. Alright, what are the symbolic representation and unit? Initial velocity is represented with U and is measured in meter per seconds. The final velocity is represented with V and is measured in meter per seconds. The acceleration of the body is represented with small letter A and is measured in meter per second square. And time represented with T in seconds. And distance covered is represented with S in meter. Alright, it is important to note three important things. Very important to note three things. Because these three things are the concept that we be applying as we proceed in our class today. Number 1, when a body accelerates from rest, it implies that the initial velocity u of that body is 0 meter per second. That's what it means. When a body accelerates from rest means that u is 0 meter per second. Then number 2, when a body comes to rest, that is, comes to the final end, which is coming to rest, it implies that the final velocity v of the body is 0 meter per second. And number 3, that when the body moves with a uniform velocity, it implies that the acceleration of the body is 0 meter per second square. So today, let's now begin to apply the equation of uniformly accelerated bodies, and let's quickly use it to solve. Now there are some questions we are going to solve today, and maybe at the end of the class I'll just go through and show you those questions now. But let's just sit right now. Kindly subscribe to this channel. Please subscribe to this channel, turn on the notification bell and comment in the comment section. Alright, let's go to class. Alright, now let's look at this example 1. A student walks a distance of 3 kilometers in 20 minutes. Calculate his average speed. Now the first thing you need to know is the parameters. You have to take the parameters of what we are given. If you look at the question, you look at this, you see distance is 3 kilometers. That is distance is denoted with S. So S is given as 3 kilometers. Then when you read through, you discover that there is an item here. We have time, which is 20 minutes. So we have T is 20 minutes. Okay. Now let's look at it. Now when we are asked to find the average speed, and average speed is V, is unknown. So we look at these parameters, we discover that the relationship between these parameters is given as V equals to S over T. But if you look at this, the 3 kilometer is not the SI unit. And remember, SI unit must be in meter because distance is measured in meter. So how do we convert this one to meter? We convert this one to meter by saying, since 1,000 meter make 1 kilometer, so we multiply 3 multiplied by 1,000, then we are going to have 3,000 meter. We are going to have 3,000 meter. Then we look at the time. Remember time, 60 seconds make 1 minute, and time is measured in seconds. So in this case, we are going to have 20 multiplied by 60, then we are going to have 1200 of seconds. So always convert to the SI unit, then we now go and substitute our values. And in substituting our values, so since our S is 3,000, so we are going to have our S to be 3,000. That's 3,000. Then we divide it by 1200. So by the time we press our calculator and we divide that value, then we are going to have 2.5 meter per seconds. So that's how we solve this question. Now let's look at example 2 now. All right, let's look at this example 2 now. A driver traveling at a speed of 115 km per hour received a text on his mobile phone. How far is he 20 seconds later from when he received the test? So let's quickly pick the parameters. Now we have the speed. We have the speed, which is 115 km per hour. So let's take the parameters. Remember, speed is represented with a v, that's our speed, and our speed is 115 kilometer per hour. But remember that in physics, the SI unit for speed is not kilometer per hour, but rather it is meter per second. So let's quickly convert this one to the appropriate SI unit. So how do we do that? Now, 115 kilometer per hour simply means that the body covers 115 kilometer in 1 hour. That's what it simply represents. So let's convert each of the parameters into the SI unit. So if I convert this one to SI unit, it's going to be 115 multiplied by 1000. Why? Because 1000 meter make 1 kilometer. If I convert this one to also SI unit, it means 1 hour multiplied by 60 minutes, then multiplied by 60 seconds, because 60 seconds make 1 minute and 60 minutes make 1 hour. So we have that. So let's quickly do the final conversion now. 115 multiplied by 1000 is going to mean 115, then 0, 0, 0, then divided by, when I depress this one, it's going to give me 3600. Now let's divide quickly. So when we divide this one quickly, so we are going to have a approximated value of 31.944444 like that. But let me just convert to 2 decimal places, the meter per second. So we have converted the V to meter to SI unit. So let's continue with the parameters now. He received the test on his mobile phone. How far is he? 20 seconds. Now 20 seconds, we have another parameter T. So our T is 20 seconds. Our T is 20 seconds. Now, how far is he suggest distance. How far, that is distance covered. And remember, distance is represented with S, and that X is unknown. So looking at the formula now, we can say V, speed, is distance over time. So let's substitute our parameters now. If I cross multiply, because I'm looking for S, if I cross multiply, then S equals to V multiplied by T. So let's substitute. Now, since my V, remember my V here is 31.94, so let's say our V is 31.94, then multiply by my time. Remember, my time is 20 seconds. 20 seconds. If I multiply together, then I'm going to have a value that is 638.88 meter. Alright, let's approximate the value to the nearest, okay, let's just approximate value, and then let's say we have 639 meter. So that is that about that example. All right, let's look at example 3 now. Okay, let's look at example 3. Now, in example 3, a body accelerates uniformly from rest at the rate of 3 meters per second square for 8 seconds. Calculate the distance covered by the body during the acceleration. Now let's look at something very important here. A body accelerates uniformly from rest. Remember, in the previous class I said that there are some concepts you must understand. That when a body accelerates from rest, it simply means that the initial velocity of that body, u, equals to 0 meters per second. So take note of that. So when we write now, we say u. So u, which is the initial velocity of the body, u, is given as 0 meter per seconds, because it's accelerated from rest. Now, the acceleration is 3 meter per second square. So our A is 3 meter per second square. All right, let's look at our other parameters that we are given now. Then we are given time parameters. So our time T is given for 8 seconds. Our time is 8 seconds. Then we are told to look for the distance covered. Distance is represented with S, is unknown, so you have to represent appropriately. Distance S is unknown. So looking at it, all the parameters given are in SI units, so there's no need for conversion. So what we just do is just to apply the equation of motion. If you look at this SUAT, there's an equation of motion that we need to apply, and that one is S equals to UT plus half AT squared. So it's very important that you master the equation of motion. So let's quickly substitute the equation of motion into these parameters now. So our S is U, and U is 0 multiplied by our T, which is 8, plus half, and AT, then multiplied by 3 times T squared, that is 8 squared. Alright, now let's look at it. Now let's begin to solve further. Then our S equals to 8 times 0, that is 0. That one has gone now. Then we now have half, that's half, multiplied by 3, then multiplied by 8 squared. And 8 squared is 64. So we have that one, 64. So the next thing, what we do is we just simplify that. Then S equals to just 3 times 64 divided by 2. Alright, let's quickly press the calculator now. 3 multiplied by 64 will give me 192. Then it's 192 and divided by 2. 192 divided by 2, then I'm going to have 96. So our S equals to equals to 96 meter. Always put the unit to the answer. So that's how you get the final answer. Our S is 96 meter. So let's go to example 4 now. Alright, let's look at this example, the next example. Now, starting from rest, a Formula 1 car accelerates uniformly at 25 meter per second square for 30 seconds. What is the distance covered in the last 1 second of motion? And number 2, what is the distance covered in the 17th second of motion? Now let's quickly look at this. Let's first take the parameters. Starting from rest, so that suggests that U, which is initial velocity U, is given as 0 meter per second. So our U is 0 meter per second because the object starts from rest. Now acceleration is also given. We have our A. So our A is also 25 meter per second square. Our acceleration is 25 meter per second square. So let's look at what we are given again. We are given time. Then our time T is 30 seconds. Can you see the way I'm picking parameters? It's very important. Now, what is the distance covered? We are looking for S. Distance covered. Now, the question is now, what is the distance covered in the last 1 second? Now, let's look at it. Let me use this chart just to illustrate. Now, the object starts from rest and it covers a distance 30 seconds. The object starts from 0 rest and times 0, and it covers a distance when it goes to 30 seconds. Alright, now, but as the object starts from rest, it covers a distance until it reaches a point, let's say 29 seconds. Now, the question is now, what is the distance covered during the last 1 second? So definitely, the distance covered during the last 1 second is going to be the distance covered for 30 seconds minus the distance covered for 29 seconds. The distance covered for 30 seconds minus the distance covered for 29 seconds. So let's quickly look for that. So how to get the distance covered for 30 seconds? So the distance covered for 30 seconds, you calculate that one, whereby you make your T to be 30 seconds. While distance covered for 29 seconds, in that calculations, you make your T to be 29 seconds. So let's quickly go to that and solve. Remember, equation of motion we are going to apply here is going to be S equals to U T plus, okay, let me just show you the board. Alright, okay, S equals to U T plus half A T squared. So at this point, we want to look at distance covered when S is 30. So let's quickly do that. Then our U is 0 multiplied by T. T is 30, then plus half A. Our A is 25 times T, that is 30 square. 30 square. 30 square. Alright, let's quickly solve that now. 0 times 30, that one has gone. And S for 30. So the S, the distance covered S in 30 seconds, now is going to be 1 over 2 multiplied by 25, multiplied by 25, then multiplied by 30 square. And let's take our calculator now. What is 30 square? Our 30 square is simply 900. So that is 900. That's straightforward. Then what do we do now? Let's quickly proceed and solve that. So our s at 30 then is going to be 25 multiplied by 900. Then you divide it by 2, and it's going to be 11250 meter. So let's look at distance now covered for 29 seconds. So s for 29 seconds now will also be ut plus half at square. So at this point, our t now is going to be 29. So our t now is going to be 29. So it's going to be 0 multiplied by 29, then plus half. Our acceleration has not changed. It's still 25 because it's the same body. 25 multiplied by now 29 square. So our s29 now is going to be, this one is 0 now. Then we have 1 over 2 multiplied by 25 multiplied by 29 square. And what's 29 square? And 29 square will give us 841. 841. So what is our s29? It's going to be 841 multiplied by 25. The result divided by 2. Just use your calculator and solve that expression. Exercises, then we're going to have 10512.5. So let's now find our distance covered for the last 1 second. It's going to be s30 minus s29, and that one is going to give us so let me show the board. Sorry for that. So s30 minus s29, and that one is going to be let's look at it. Remember, it's going to be 11250, then minus 10512.5. So let's do that now. Now let's look at that. 11250, then minus 10512.5. So it's going to have a 737. So there's going to be 737.5 meter. We are going to have 737.5 meter. So that's how we calculate the distance covered during the last 1 second. Now let's look at how do we calculate the distance covered for the 17 seconds now. Alright, let's look at the distance covered for the last 17 seconds. That one is going to be distance covered for 17 seconds minus distance covered for 16 seconds. That's going to give us the distance covered in the 17th seconds. So let's continue our parameters. Remember, our u is still 0. It's still 0 meter per seconds, and our acceleration a is still 25 meter per second square. Our acceleration is still 25. All right. Sorry, pardon for that. Let me do something very. So let's look at our time. Now our time now, okay, as a time. Now in this case, because we are looking for distance covered in the last 17 seconds, so our time now is going to be times 17, and we look for time distance covered for 17 seconds as our t2, and we are going to look for distance covered for 16 seconds. So the difference between the distance covered for 17 seconds minus distance covered for 16 seconds is going to give us the distance covered for the 17 seconds. So let's quickly look for that now. We are going to have, remember, s is what we are looking for. Then we can now say s equals to ut plus half at square. S equals to ut plus half at square, and u is 0. Remember, the body starts from rest. So in that case, so we are going to have s during the 17 seconds. For 17 seconds is going to be u, that is 0 multiplied by t, which is 17, plus half a, 25 times 17 square. So s for 17 seconds is going to be 0 now, plus 1 over 2 times 25 multiplied by 17 times 17, and 17 square is going to give me 289. Then s for 17 is going to be 289 multiply by 25, then divide the result by 2. So when I divide the result by 2, then I'm going to have 3612.5. So that's the distance covered for 17 seconds. Now let's look at distance covered for 16 seconds now. S16 is now going to give me, that one is going to be 0 times 16 will give you 0. So we are going to have a half multiplied by 25 times 16 square. So in that case, then 16 square is going to give me 256. So S for 16 seconds is going to be 1 over 2 multiplied by 25 multiplied by 25 multiplied by 256. So we are going to have that one multiplied by 25, then divided by 2, that is in half. So we are going to have 3200. So to now know the distance covered for the last 17 seconds, S for the 17 seconds is going to be S17 minus S16. So what is X17? X17, don't forget, it's going to be S17 minus X16, and X16, that one is giving me 3200, or sorry, S17 is 3612.5 minus 3200. So if I subtract that value from so we are going to have 0.5, then we are going to have 412.5 meter. So that's the distance covered for the last 17 seconds. Thank you. All right, let's look at this one. A body uniformly accelerates from rest at 8 meters per second square. In how much time will the body travel a distance of 2.5 kilometer? So let's pick parameters. The body uniformly accelerates from rest. So from rest shows that we have u to be 0 meter per second. That's from rest. And at the rate, that's acceleration, at the rate a is 8 meter per second square. So the question now says, in how much time, so we are looking for time t, in how much time t will the body travels a distance? Our S distance is 2.5 kilometer, and 2.5 kilometer now, if you want to convert, remember that you need to convert whatever that is not in SI unit to SI unit. So 2.5 kilometer is not SI unit. You have to multiply that one by 1000 in order to convert it to SI unit, so which is in meter. So you're going to have 2500 meter. Now if you look at these parameters too, you discover that what are we looking for? We are looking for S, and because we are looking for S, we're looking for T. So what we'll do here is the equation of motion we are still using here is T. S equals to UT plus half AT squared. That's the equation of motion we are using. So let's substitute the parameters that we have. Then our S is, so I'm going to have 2500 equals to U is 0 and my T is unknown. Then plus half was my A, 8 times T is unknown, T squared. So let's solve mathematics around this place now. So 2500 equals to, 0 times T is 0. So I'm going to have 8t squared divided by 2. Okay, so what's the next thing we do? We can divide 8 by 2. So we divide 8 by 2, and I'm going to have 2500 equals to 40 squared. Alright, so when we have 40 squared, so the next thing we divide both sides by 4. So 2500 divided by 4, that one is going to give me 625. So it means t squared is going to give me 2500 divided by 4. So it means t squared is going to give me 625. So how do I get my time? My time is going to be the square root of 625. And what's the square root of that 625? The square root of 625 is 25 seconds. So our time in which the body is going to take to travel a distance of 2.5 kilometers is simply 25 seconds. So let's go to the next example. Okay, let's look at this example now. A particle starts from rest. So from rest, that is u, 0 meter per seconds. When an object starts from rest, u is 0 and moves with a uniform acceleration. Acceleration is 4 meter per second square. What is its velocity? Now, they are talking about another velocity. So that's is telling us that they are asking us for the final velocity. What is its velocity after it has covered its distance s and has covered the distance of 8 meter? All our parameters are in SI units. So let's quickly look for equation of motion that fits this. So equation of motion that fits this is v square equals to u square plus 2as. So let's quickly look for our result now. So v square, since u is 0, is 0 square plus 2 times 4 times 8. That's 3s. Then v square equals to 2. 0 square is 0. Then 2 times 4, 8. 8 times 8, 64. That is 64. Then v equals to the square root of 64. And our v equals to 8 meter per seconds. So that's how we get our result. So let's look into the next example. Alright, let's look at this example now. A motorist traveling at 120 km per hour sees a broken down truck at the middle of the road and immediately applies its brake and comes to a stop immediately with a uniform retardation in 20 seconds. What is the distance traveled after the brakes were applied? Now let's take the parameters now. The body is traveling, so because it's traveling, our u, initial velocity, is 120 km per hour. We are not told that the body is starting from rest. So they say it's traveling at that velocity. So what we're going to do is we'll need to convert that into convert it to meter per second. Remember how to convert is just say 120 kilometer in 1 hour. So we're going to say this one is going to be 120 multiplied by 1000, then divided by 1 times 60 multiplied by 60. So this one is going to give me 120,000 and divided by 3600. So let's do our conversion now. Do our conversion appropriately. We are going to have 333, that is 33, sorry, 33.33 meter per second. So that's our unit now in meter per second. So we have converted the initial velocity from 120 km per hour to meter per second, and that one is 33. So let's continue. He sees the broken down truck at the middle of the road and immediately applies brakes and comes to a stop. Remember, when an object comes to a stop, the concept tells us that the final velocity of an object is 0 meter per second because it has come to a stop. Now, with a uniform retardation in 20 seconds, our time is 20 seconds. Alright, what is the distance traveled? What is the s traveled? So I look at those parameters now, s, v, u, t. So the parameters we are going to use, we can quickly simply use s equals to 1 over 2 into bracket u plus v close bracket t. So we use that formula. So when we use that formula, then we can say s equals to 1 over 2 the bracket. What's our u? Our u is 33.33 plus 0 and into bracket t, and our t is 20 seconds. So let's quickly press our calculator and get our value now. So we multiply by 20. So we multiply 33.33 multiplied by 20. So we are going to get 666.67. Then we divide our result by 2. We divide our result by 2. Then we are going to get 333. So our is going to be 333, approximate to 3.33. So meter. So that's our distance covered. So let's look at the next example. Okay, let's look at this example now. The velocity v of a space shuttle in a time t is given by v equals to 25 plus 3t square. find the instantaneous acceleration at t equals to 9 seconds. Alright, if we look at this, let's take our parameters. We are given v, and v is 25 plus 3t squared. Then we are told to find acceleration. Acceleration is unknown, and then we are given our t. Our t is given as 9 seconds. Now, how do we find acceleration? Remember that acceleration is change in velocity over time. Acceleration is change in velocity over time. Whereby velocity, remember this velocity, when I say change in velocity over time, let me do a rough sketch here. You know that change in velocity simply means final velocity minus initial velocity. So if this one come into these parameters, it becomes a equals to v minus u over t. And by the time we cross multiply, it's going to give you v equals to u plus at by the time we do the final thing. So it becomes equation of motion. So let's go back here. But in this question, we are given v not as a value, but as an expression of 25 equals 25 plus 3t squared. So we remember something in differential calculus. We know that we can differentiate using this element, that if y is x raised to power n, then the y over the x is given as n x raised to power n minus 1. Well, this is a concept in calculus that we can just simply do. So let's apply that calculus to this expression. We want to differentiate this one in with respect to time, because acceleration is just change in velocity. It's just like saying dv dt. You differentiate velocity with respect to time. So acceleration in this concept, if I differentiate velocity with respect to time, is going to give me 3 times 2t raised to power 2 minus 1. So the acceleration is going to give me 6t raised to power 1. So that's what I'm going to have. So that's our acceleration. And since our time now is 9 seconds, then acceleration is going to be 6 multiplied by 9 raised to power 1. And then we're going to have a final result. And 6 multiplied by 9 is going to be our final result. And 6 times 9 is going to give us 54 meter per so 50 meter per second square. So that's going to be our result for acceleration after that particular time t. So I believe we have done enough as far as these examples is concerned. So I will just give you some of the exercises you can practice with, and if you have any question, you can just ask question. But make sure you like this video, subscribe to this channel, and comment if you have anything to comment. So next class, we'll now be looking at the next thing, which is equation of motion under gravity. Thanks for watching. Alright, thank you for joining the class. I believe you've learned a lot from this class. So I just want to go through the question once again. Let's just go through the questions once again, so that in case if you have not noted the questions, so that you can just put the question down. So this is questions. This is number 1. You can just pause the video, you write the questions and see how we solve. That's question 1. That's example 2. So that's example 2. And just pause the video and copy it. And this is example 3. This is example 3. This is example 4. This is example 5. And this is example 6. And this is example 7. Alright, for more practice class, I want you to just go through these exercises. Look at these questions, similar to what we have done in class today. So just practice these questions and choose your answers. So those are YA questions, and some of them are JAM questions. So just look at these exercises. You can pause the video and solve. If you're correct, you see the answer there. So let's look at this. Just pause the video and copy the question. The number 5 and 6. You can pause the video and copy the question, and you check the answer after you're done. And number 7 and 8, you can do the same thing here. So pause the video. Alright, number 9 and number 10. That's number 11 and 12. Okay, number 13 and 14. Alright, in conclusion, let's just remind ourselves the equation of motion once again. V equals to u plus at S equals to ut plus half ut square. V square equals to u square plus 2as, and s equals to 1 over 2 into bracket u plus v close bracket t. Next class we shall move into acceleration of body under gravity. Alright, thanks for watching this video. Please make sure you subscribe to this channel, like this video, comment. If you have questions, you can just comment in the comment section, and you can share this video. Thank you for watching my video. Bye. God bless you.